I want to go to Bob Greenyer. Bob, welcome, sir. Oops, sorry.
It's a very, very great pleasure to be here and to share some of our work
Oh no, it's
since we
absolutely
last met.
wonderful. Yeah. Well, and I, you know what? I did a StreamYard with you on, I think it was Bernie Conkin's channel, right? Not too long ago. You were in Japan then, so.
That was quite some time ago that I was in Japan. That was, I guess, April last year. I was visiting Dr. Takaaki Matsumoto, who sadly passed away. But I'm going to actually be going there at the end of this month as well, because the family are handing over the papers of the great scientist who really pioneered ball lightning as a means of nuclear transmutation work.
See, you've got your traveling legs. You're I haven't been traveling that much lately. I'm going from my next trip here is Seattle to Portland, and I'm like, how am I gonna do? Like
You'll be fine.
like please, I'm taking a train though. I didn't have the energy for the aircraft
Right, fair
after
enough.
getting waylaid in the airport for a day last time. I was like, I'll take the train. What could
Yeah,
possibly go wrong?
I think that's probably quite common. So Phil Dubois has come down here to do some mass spectrometry tests. I'm here in Santa Cruz in California with Alan Goldwater in his Magic Sound Lab, as you can see, speakers and
Yeah,
sound
it's
treated
amazing.
room here. And he was coming via Chicago, and his plane was 3 hours delayed, and so he missed coming the day he was meant to be here. And then they didn't send his bag in time, so he had to wait for a bag with all the parts for the thunderstorm generator to be sent down. But anyway, it's all good. We're doing tests, and I've stepped away from the tests to share some of our experiences and thoughts with regard to.
Yeah. So do you have now? Did you have like a PDF that you wanted to upload, or did you want
I
to
have
share a
that. I've
browser
got a
screen?
presentation. If I can share a screen, that
Yeah.
would be great.
And you're a pro with StreamYard, so
I don't know whether I'm a pro, but we can see what we can do here.
well, Bernie is the pro. I lean on Bernie. Like
There we
every
go.
now and then I'll
Yes.
call him Bernie, help me.
So maybe he can help. So maybe I can see what I can do here. If I play, I probably want to play this in a window because
He's kind of like Batman. I throw up
is he?
I throw up the Bernie signal, and he'll just kind of appear out of. It's like a genie. There's a poof of smoke, and there's Bernie. He's like,
Okay. So I mean, I'm ready to fire away. What I'm going to do for you today, as I'm going to talk about, I'm essentially going to add some bits into my ICCF 25 presentation that I
yeah,
gave
and
last year.
let me see. I don't see. Oh, well, I guess just put it up when you're ready. I don't see it yet, but
Yeah,
whenever you're.
I've not shared my screen yet, so let's
Sorry
try and
about
do
that.
that.
Well, yeah. Well, why don't I take myself out and let me thank you again in advance because, um, and you've presented before. We have about an hour today, but, I mean, you have spoken for like 2-3 hours easily. So,
Well, I'll try and hit the hour mark, but I've got some really nice stuff. I
okay.
reanalyzed, and this will be at the end of the presentation. I reanalyzed, if you can remember that very famous sample that John Hutcherson showed in many of these
Yeah.
videos. I think you've actually seen it. It kind of has. I think it's from a drive shaft or a crankshaft or something. It's very thick, about
Yes.
that diameter, and it has like a stair step around it.
I
That was
think I've held
analyzed.
that. I've held that.
I've held it too. So we're joined by at least that piece of metal
Yeah.
and John Hutcherson. So and that was analysed by George Hathaway back in the day. I think in the 1980s or 90s. It was also analysed by the Max Planck Institute and by Ken Shoulders and by other authors and researchers. I actually visited at the end of 2022 George Hathaway in Toronto, and he gave me some fragments of that. And
Oh,
last year I actually analysed that, and I've just got one image to share now. I'm going to do a much broader presentation
yeah.
on that.
Let me take myself out and I'll
Okay,
say, take it
let me
away,
see if I
sir.
can
Take
share
your
the
time.
screen first. Share screen is the easiest with two monitors. I've got that. Screen sharing works best on a good. Okay, all right. Share screen. Now what? Window entire screen. Let's do that. There we go. Right. Can you see that?
There we go. Decoding EVOs. Yeah.
Yes.
Thank you again, sir.
Okay, so let's do this. Right, so my name is Bob Greenyer. I'm a volunteer with the Martin Fleischmann Memorial Project, and thank you for joining me this 11th of May 2024, and for Tim Ventura to allow me to speak at his APEC conference here. So what you're looking at on the screen here is one of the most famous samples by John Hutcherson, a resident here about 4 or 5 hours north of me here in California, where I am at Santa Cruz today. And it is the sample where a steel knife sank or teleported into a block of aluminium. And then what he did was he shaved that off, and he revealed the fact that this was embedded into the sample. Now, why this interests me, I've actually currently got a section of this on loan from its author, and we've done various tests on it. I'm going to do a few more tests on it before I send it back in the later this month. But anyway, it has the steel here. This is steel. This is on a Dyna light microscope. And then this is the aluminium. The tool marks here are where he used a planing tool to remove the aluminium from the top and reveal the section between the steel and the aluminium. The thing that really interests me here is this division here all the way around the steel. And it looks like it's chewed away at the aluminium and not so much at the steel. And this is consistent with our understanding of exotic vacuum objects. So I have, in other presentations I've presented, I believe that exotic vacuum objects formed a skin around the iron here. And it basically, they're like little micro machines that caused it to be able to move into the aluminium, turning it to a kind of jelly, but on this perimeter, and it just moved in and swept the material around it. Of course, with the electromagnetics involved and the standing waves, maybe it did this so instantaneously, it looked like it maybe teleported in. So the structures themselves tend to produce elements, and the elements that they seem to produce most of is carbon. And I've argued in the past that this is because if they are effectively denaturing the matter into prima materia or a quark gluon soup or something like that, when the matter reforms, it could form to a proton, but that becomes hydrogen, that becomes a gas. If it forms helium, that becomes a gas, or alpha particles. If it forms beryllium, that decays very quickly to alpha particles, and that becomes helium gas. So the first element that it can synthesize, which is effectively an alpha conjugate nuclei, alpha conjugate being one of the, if not the best packing density of matter that the universe provides in ordinary dense matter, is carbon. And so I believe that's why you see a lot of carbon. Of course, when carbon's there, it has lots of different allotropes, and it's got a high melting point, boiling point rather, and so it's very stable. And so this is why I believe you get carbon forming. And so, you know, some might argue that somehow John Hutcherson cast this piece of metal into this other piece of metal. But given the fact that we have seen fluidization of metal below its melting point in indium exposed to Amasa gas in Japan in 2019, and other kind of similar processes going on in ceramics and metals, I think that there is a better than zero odds that this is actually as a result of exotic vacuum objects. It was these kind of things going on, and this is a scanning electron microscope of a different part of that knife. It was these kind of things, in fact, that interested the militaries around the world, and also Ken Shoulders was brought in, and it was in, I think, about 1982, and after about 4 or 5 years, he came out with the EV, A Tale of Discovery, which you can download from our Facebook page. And this was his journey towards kind of basically understanding these structures. Okay. Now, my understanding has taken me on a journey where I came across a Russian scientist. I unfortunately never had a chance to meet him, but I'm going to dedicate my talk today to one Vladimirovich Dubovik. He died April the 27th, 2024, after suffering some dementia and neural decline these last couple of years. He was born in March 27th, 1938. He graduated from the Moscow Physics Institute approximately in 1962, and it was him that discovered the toroidal moment as part of his PhD thesis, which he published in 1967. The toroidal moment was only verified in the West 30 years later in 1997, and right now it's starting to be understood, and we're going to be touching on this. Now, what we are looking at here is a frantic, desperate attempt in 2000, I believe, 18, in January or February 2018, of Vladimirovich Dubovik trying to explain to the people in the Moscow Friendship University, and I've actually presented in this university, I believe in 2015, in February 2015, I gave a presentation on the work of the MFMP, for which I volunteer. There's a meeting, an emergency meeting between all of the people involved in this field, most actively, in this room where I had an opportunity to present earlier. And it was about the death of Yuri, who ran the conferences for over 25 years in Russia. And he had died, and they blamed it on this strange radiation. And he is describing at this point, as far as I understand it, how if you mess around with this type of radiation, it can actually extract the life force in a beam from your body. And he believes that this is what killed Yuri Bajatov. And so they ceased working until they understood strange radiation a little bit better. Okay, so I'm going to go over mostly some aspects of my presentation that I gave at the International Conference on Cold Fusion, or the ICMNS conference in Szczecin in Poland, in number 25 in Poland last year. And I'm going to add some extra slides in there from other presentations since, and I've got some absolutely totally brand new stuff, really killer, at the end here for you to consider. Okay, so this is Martin Fleischmann, who you may know from the cold fusion label attached to him with regard to what I believe is the same process going on in all of these different systems. This is an experiment by Henk Uren, one of our open researchers in the Netherlands. And this here, this helical beam coming out is, in my understanding, a coherent matter wave that comes out of a particular part of one of these ball lightning-like structures when they decay, or their substructures. Okay, and we've actually proven that with scanning electron microscopy recently, and the specific place at which it comes out of these decaying structures. And so this is from Martin Fleischmann's interview in Infinite Energy in 1996. He says, "As I told you when we were talking before, we had about 4 projects which we were working towards. One was to do with gravitation. One was actually to do with the behavior of electrons in metals. We actually started to collect equipment together to investigate the behavior of electrons in metals." Okay, so the metal-electron bond is very, very interesting. Okay, it's not like a covalent bond or an ionic bond or a polar bond. It's really it's a different kind of species of electron interaction. And it's one that these exotic vacuum objects seems to interact with. Okay, so you can see here some traces that were caught in a David Boutlier experiment from Canada, and that there are these things orbiting, pairs of things orbiting around each other. Here is another experiment from Henk Uren, and using the 14.5 stops of a Sony A1, we were able to look into a plasma ball at the bottom of the chamber. Okay, and we were to see that within the plasma ball there was 2 spots, and within the 2 spots you have more 2 spots, and they happen to be at a particular angle. Okay, so what you see as a little flash in the tank here is actually a much more complicated structure going on. What is that structure? Well, hopefully we'll find out. Now, these beams, they seem to have a forward-looking vector that influences matter in their forward direction. So if you look at this trace here, it's coming up here, but it bends around another trace. It then comes along here, and as it comes along here, it bends another trace around it. Okay, and then the one that's bent round it influences it, and it comes back, and then it bends in the other direction. And then as it's tracing into this direction, before it hits this point up here, it affects the path of another trace. These things are not caring about the cathode, which is down where you see this bright spot here, and they're not caring about the anode here. They only care about each other. And this is something that Ken Shoulders talked about. But they have this highly focused beam that projects out in front of the structure, which I would argue is a gravitational wave beam. And they have this non-radiating boundary, this specific boundary in which they can have no effect on their same kind of structures. But when something or ordinary matter comes within that boundary, if it possibly can, then it has extreme effects. Okay. So where did all this start? Well, what Ken Shoulders did was he went back to the work of Winston Bostick as one of his references, and the book of Lafferty as well, from work done in the 1930s onwards at Bell Labs and so forth. But what Winston Bostick was doing, he was working on Project Sherwood at Lawrence Livermore Laboratory and a couple of other labs, Los Alamos and so forth here. And he was trying to convert the hydrogen bomb into domestic fusion. Now, if you actually see some hydrogen nuclear detonations, you will see that they have this specific structure. And I've talked about this recently, this magnetohydrodynamic structure. And sometimes there are a couple of experiments where one in particular where they used a tactical nuclear weapon test. This was to be launched from artillery shell. They actually saw a plasma toroid, literally extremely clearly in there. Okay, so there was an understanding at this time that these were some kind of plasma toroids and so forth. So in order to make this controllable, he went into the lab and he was firing from, and I'm going to show you here. This is a ceramic gun. Where he has two deuterated titanium electrodes, and he puts, say, 10,000 amps through them in a very short time frame. It produces a plasma which contains the deuterium ions, the titanium ions, and it has the current going round with a magnetic loop around that. And there is a so-called magnetic reconnection here, so you get a self-contained pinch in a torus. And then he fired at least two of these from opposite sides of the chamber, and they would form toroids that would then spin around their center of mass. And he called these things plasmoid. There is someone that says oid is a certain type of spiral in Jewish law. I haven't verified that, but this would be a plasma spiral type thing. Effectively would be the translation of that. Anyway, so he was saying by 1957, he was publishing this in mainstream journals and newspapers even. He was proposing that this could be the basis for the structure of all matter from the subatomic to the formation of galaxies. So in that respect, he was not too unlike Kelvin, but he was having something that was more visceral for people to connect with. And then he said that he proposed that aspects of his findings could lead to ultra-fast propulsion of up to 450,000 miles an hour. To put that in context, if you were already traveling at 450,000 miles an hour, that would get you to Mars in 13 days. In 13 days. Of course, you would need to accelerate to that, and you would have to decelerate, so maybe 4 months or whatever. But just using this approach, you might expect to reach that in 14 days. Okay, so I don't know whether you're going to be able to hear me this, and someone might like to say, but I will share these, and I've talked about this in the past. But anyway, when Shoulders, in his EV, A Tale of Discovery, there's a link to it there, his 1987 conclusion says, by some irony of fate, we may have folded back upon ourselves and now have accidentally discovered that the EV is an ideal monopole oscillator. This oscillator is the perfect generator for vector and scalar potential waves without contamination for E and B fields. These waves can be thought of as longitudinal waves in the vacuum. They are largely undetectable by standard electro or magnetic detecting means, but are readily accessible to the monopole world. There appears to be an incredibly large number of useful phenomena yet to arise from using the potential effects that are not immediately accessible to the force of electro and magnetic fields. This phase-determined, force-free world will certainly be another chapter somewhere in the future. And my friends, I think we are entering that chapter. Now, as I said, it took a long time for the West to catch up, but here in Nature Materials in 2016, electromagnetic toroidal excitations in matter and free space, this description largely matches this. And you can see here at the end, the last sentence is, the physical significance and detectability of these potentials are not established and are being actively discussed in the literature. So here we go, 2016. This is 1987. It almost appears like these things are moving on a glacial pace. This is the overall structure of a non-radiating configuration. What do I mean by that? Well, when you have, it says, a toroidal dipole. So we're going to be talking about the toroidal moment, the toroidal dipole here, which will be present effectively in a two of those plasmoids coming together. And I'll show you that in a minute. Represented by a solenoid with oscillating poloidal currents. This is the oscillating poloidal currents. An electric dipole here, representing by a pair of opposite charges oscillating on the same frequency as its currents. Then basically the electromagnetic waves that are combined from this end up cancelling at a distance. So there is zero electromagnetic waves detectable or emitted out of this, but the vector and scalar potentials still exist. So this is the same thing, 87, 97, 2007, 2017, you know, another 30 years. Okay. So sometimes it takes a lot of people to catch up, a lot of time to catch up. But anyway, when you'll see later is actually that when you have a fractal toroidal structure, then you don't actually need this oscillating dipole. The actual toroidal moments cancel and you get a non-radiating boundary. I'm going to play Tom Bearden here, but maybe you will not hear him.
There's one other thing we must say about that. There is emerging in the last few years, has emerged in orthodox science at an advanced level. What I would say is the very beginning, but it's moving pretty fast. Theory of force-free fields. And these are getting very close to what Tesla is doing. They haven't added the anti-wave back in yet, but they're getting close. At least they're eliminating the overall force and doing something else with the electromagnetics that remains.
So could you hear that? Just let me know in the chat if you can hear. That would be helpful. Okay, so did you hear that? Because that will be useful later on. Okay, so in the Lion reactor here, the sadly departed Neil Crichton Gould, he gave me this reactor because the project were keeping individuals that were wanting to share their work. If they didn't want to be open about who they were, we were maintaining their anonymity. He shared this. It was based initially on an experimental proposal I made in 2013, and he ran it. It's got nickel and diamonds in here and deuterium and so forth. Okay, you heard it barely. Okay, all right, I can maybe fix that. Let me see. Okay, so on that, we found structures that did look like galaxies. This is a 2-order structure, and this is a 3-order structure. This is right rotation with a hole. This is left rotation with a lump. So that tells you something about what's going on. Here is a 4-order structure with right rotation. And here is a 5-order structure with right rotation. So the idea that Bostic had that potentially there was the ability to form, galaxies, you're seeing something again similar to what he had, but these are frozen, not in photographs of plasma moving in a chamber, but in actual solid material. So my journey of connecting with first hydrodynamic structures and then magnetohydrodynamic structures really started in 2017 here in Mumbai in Suhas Ralkar's lab, and I videoed in an ultrasound chamber cavitation bubble structures, and in there I saw this particular structure here, It has a wave function on it, but within it, on regular spaces, it has helical waves coming in and merging into the overall structure. So I thought that was very interesting, parked it in my brain. And then as things became more, and that's actually the video of the effect going on there. So I'll just turn off the audio there. These are the cavitation structures merging and joining into each other. But effectively, they are the same thing as these kind of Kelvin type smoke rings. And this is by... Oh, what? This is alien scientist Jeremy's video image here with a laser cutting through it. So you can see the same kind of structure going on. And this is a screen grab from part of this video here, where you can see this overall sort of, it's kind of like a heart shape with this beam coming in. Now, what you can see here is everywhere where you're seeing this white, that is because bubbles have formed in the fluid because of depressurization of that part of the fluid, which means the bubbles are coming out, they're expanding, and then they become reflective to the light that I was shining from the side. This means somehow in this entire area, there is some depressurization and compression going on in the center of this structure. It was very weird for me to see this, okay? Because this is almost like a flat structure. It's like two discs that are rotating around, okay, one kind of on top of each other, just like Bostic had shown. And it's propagating in this direction. Moreover, it produces a depressurized beam, which is some sort of vector that comes out of the back. It disrupts the water at a distance. And when this gets disrupted, periodically you see this stuff shooting into the back of it, okay? And you can often see these things merging in this video up here. Okay, so we've actually seen on this particular sample, which we received in the effects of Neil Crichton gold, exotic vacuum object impact structures on the end of this communication device, a Marconi style spark discharge type or a spark discharge type radio transmitter. And so this would be, you can see how old it is because it has no plastics involved in the installation. This is just a cotton thread. And it was amazing to find on this thing that was probably late 1800s, the same signatures of spark Evo production. So to the best of my knowledge, this is the earliest device ever showing this type of effect. So basically, EVOs are formed by essentially charge separation. You can do that by abrupt dielectric barrier discharge. Tesla used an air gap for a disruptive discharge. This is what Ken Shoulders did, but also what John Hutcherson did. Adamenko used a dielectric ceramic barrier, and this has been 100% verified by the US nuclear fusion program. The device was transferred from Kiev in 2015, verified up to 2017, and then is in Brookhaven National Laboratory as part of the US fusion program. So 100% this works. Shear turbulence and helical injection into charge-separated fluid. So basically, wherever you get these things, and we've looked at various things, Tornado, Windhex by Frank Polivka, our Ultra experiments, which we've done some work on this weekend, Klimov's inflow plasma vortex. There's a European group that is doing something similar with that kind of technology, and the global environmental energy technology of Paul Pantone. You can get this, and we've shown this and replicated what we showed with HHO or a Mars gas on tungsten rod, HHO and an angle through carbon tube by Stankovic in 2019. And Klimov's plasmatron, which was this was formerly secret research, but because Stankovic showed this in 2019, Klimov revealed that work, which we published on our website. And then the Plasmac Colloq model of ball lightning and the protosphere. All of these things, and including the Usharenko effect, I'm looking over my monitor there. Essentially, what you need is an impact of over 5 electron volts for hydrogen isotopes to do this. And as I'll show you later, it takes 2,000 to 4,000 times more energy to create the effect with elements beyond lithium. Okay, so what do we see when you do the charge separation? This is in a Shakhparadov experiment, creating topological monopoles. And this is a Mobius strip, and I'll say why that's important in a second. but you have positive vortices and anti-vortices, and you have negative anti-vortices and vortices propagating in alternate directions with the high current shock pulse that's going into this Mobius strip. And this leads to the topological monopole, and you'll see the effect in a minute. Interestingly, the same thing is represented on this ancient brass body breastplate from Finland that I took in the museum there in Helsinki last year. Exactly and correctly represented with the flux tube going between the two. Okay, so why did they know that hundreds of years before Christ? This is the effect. You seem to get a projection out in some cases. I would argue that this is the yang. The yang is always brighter because it does matter disassembly. And the yin is darker, but it's still bright because it's doing matter assembly and it extracts energy at a distance. And this is a zero albedo feature. So these are the kind of things that Dubovik was warning against, in my view, where you could give someone cancer with a beam this way, or you could actually stop their heart like Ninel Kuligina did with telekinesis type powers. And you can go and look at it. She stopped the heart of a frog, but she then restarted the heart of a frog. And then one of the researchers came in and said, "Oh, can you do it to me?" And she stopped his heart. And I would believe that she was essentially channeling the energy using this and essentially restarting the heart of the frog by and I would argue that this is chi energy, and we'll get into why that is. Okay, so what is going on in this Mobius strip? This is a Mobius strip. This is a simulation of the Mobius strip on a Tesla graphics card back in the early 2010s. What you have actually is what's called a phase singularity. So here, this is a sort of Penrose staircase, kind of Escher type drawing, and you're going round one way or going down the other way, but you're actually not going up or down. You're effectively staying with the same point. And that's what's called a phase singularity. And two structures that are well known have a phase singularity. One is the Mobius strip done, and the other one is the vortex soliton. And what we are looking at is vortex solitons, but also vortex solitons fractally joining into clusters of vortex solitons. So what is the fractal toroidal moment? So Dubovik established the toroidal moment. What is the fractal toroidal moment? Well, we established what that is. But basically, building on the work of Jakov Zeldovich in 1957, Vladimirovich Dubovik, he established the toroidal moment. And essentially, if you have a magnetic moment coming from this electric current, like you could imagine is in your initial discharge in the plasma guns of what's his name? Winston Bostick. If you have at least two of those, which he did, and you have them coming in opposite directions, you end up by producing a toroidal moment. This could not be known to either, or at least it wasn't understood to be known, and he never talked about it within his lifetime to Winston Bostick. It was not known to John Hutcherson. It was not known to Ken Shoulders, although Ken Shoulders was getting close as to the implications of what it was without understanding the maths behind it. Okay, so then if you get that toroidal moment structure and you put that in a loop, you end up with a hypertoroidal. This is what it's called in the West. They call it a supertoroidal in Russia, but I call it a fractal toroidal because there's hypermarkets and there's hyper this and there's hyper that and there's super and whatever, but fractal intuitively to me explain the phenomena. I actually, in 2017, there is a subsequent to calling it the fractal toroidal moment, I realized that in 2017, a Russian author in a mainstream journal, I think it was Nature or Science or whatever, they actually called these fractal toroidal structures, they actually called them a fractal current structure. So there's due credit to be given there. Okay, so this was on the Lion device here. And it has this disruption beam that comes down, and it's twisting and fluidizing and twisting this copper oxide here at a temperature well below its melting point. It has a hole in the middle where the matter seems to have collapsed. Here's a much bigger structure, and essentially this is from Science in 2011. So Science journal, major peer-reviewed journal. This is predicted toroidal moment structure where you have a oxygen atom in the center, and then you have copper and copper and copper and copper, and you get one current loop here and a counter current loop there, and that produces this toroidal moment that comes out here. So this is copper oxide here, and so is this, and so is this. So this is theory published in a mainstream journal. This is the physical manifestation, and you only need two, as presented here, to produce the most basic form of a toroidal moment, and that is what Bostic was doing. To try and convert real fusion in a hydrogen bomb into domestic energy source. Okay, so here it is blown up, and on this basis, in January, in a dream 2018, I came up with this toroidal structure with these vortical kind of driving forces going on with the vortex and the vortex and the anti-vortex structure, and that this would pull something into a point, not coming out the other side like has been drawn by other people. It is a point. It is a phase singularity. Now, you might get a beam coming out the other side, but it's not a symmetrical structure. Okay, you might even get something coming in this side, but it's not this coming out that way, right? And this is it on the HHO on the tungsten that I did in 2019. It's the decompression of the ether at this point is so strong that it's converting, in my view, the tungsten to this strontium here and this cloud, this diamond film here. Remember, carbon is the thing that this system likes to produce most. It's been observed by many authors, Takaaki Matsumoto, by S.V. Adamenko, by Mikhail Solin in their respective patents and proven works. And so this is a carbon film here, and in here, in the vortex and the anti-vortex, show it that it's one on top of the other. You get all of this typical stellar synthesis almost instantaneously produced by HHO. That is a charge-separated material burning in a plasma in a vortex, producing a magnetohydrodynamic structure that is then producing this fractal toroidal moment that is leading to the destructive disruption beam. Okay, so here's a whole bunch of different things arranged here on the paper. This is the hydrodynamic structure I showed you earlier. This is the hydrodynamic structure interacting with the aluminium, and it produces the Om shape, which is what the Sanskrit and the first religion would tell you is the way to create things. It's the most important thing. And here is a ball lightning produced in a Hank Urine experiment, which I imaged, where it impacted onto a fused quartz, and you've got the caduceus beam. This is where the disruption beam comes down, or arguably goes back in. This is on a piece of aluminium foil. On one side, you have lighter element, boron, made by extracting oxygen effectively from the aluminium. And over here, you have, with this spiral galaxy structure here, you have calcium synthesized, which some isotopes of calcium are oxygen plus aluminium. There's no boron on this side, and there's no calcium on this side. This is the yang, it's breaking matter apart. This is the yin, it's assembling matter. It is exactly and precisely the yin-yang, which is how another belief structure believes that everything is made, and so on. Okay, so this is the Sothic triangle. The Sothic triangle is always associated with the Ankh, and the Ankh is this part across here, and everything below the loop, the sort of top of the Ankh, which was changed in the Christian cross, that is, according to the Egyptians, the secret to all hidden technology, and it is, by the way, the structure of a topological monopole. Okay, so how did I arrive the fractal toroidal structure? Well, this is indium foil exposed to cavitation structures with very similar structures observed in Matsumoto. But I found at least 3 different quantization levels. In fact, I found 4, but let's start at the n-2. You have a yang force here. This is an outie. You have a yin force here. This is an innie. And those, if you rotate those 90 degrees orthogonally to that, and you can produce this structure, which is viewed from the side. You can see the apple core going through the torus here. This is from the top. This is a D4D structure here. This is a D4D structure here. And this here, if you rotate this 90 degrees, it goes around here. This has 48 subdivisions, which we later found out is likely the maximum that you can have in one of these structures. This is all on a Hutcherson aluminium sample that was produced in 2007. Okay, so this is the fractal toroidal structure that I produced. It is exactly and precisely a wheel within a wheel within a wheel, a wheel within a wheel within a wheel. Okay, and these bind together with their toroidal moment. I initially thought it was their electric and magnetic fields, but I believe it's now the toroidal moment. And it's self-similar, so you can imagine that the third orthogonal direction in the XYZ axis, when you get down to this point, is effectively the same as the overall structure. And I argued at the time that I published this on 17th of February 2020 that this probably is the structure of the physical vacuum, and this would lead to all kinds of things like teleportation and faster light travel. I will go into those at a later time. Okay. So I don't know whether this will play, but you should be able to see the video. There's two concepts here to be able to understand this. One. So, of course, everyone knows that as you pull in from the center, if you've been on a roundabout, your angular velocity goes up and so on. But anyway, okay, so using those two principles, if we have a phase singularity at the center here, now bearing in mind in these fractal toroidal structures, the matter does not go through there, it gets cohered, it gets phase synchronized, and it becomes effectively a Bose-Einstein condensate. So if you can imagine these electrons are coming in here, they're not electrons, they're coins. But if they were electrons, they have Pauli exclusion principle. So as they come into the phase singularity, if they get closer than 180 degrees out of phase, they will push it forward and they will end up 180 degrees out of phase, then leading to a Cooper pairs and a condensate. So this effectively would lead to essentially unlimited amounts of electrons to go into a defined radius. And this was, I think it's Perevoschikov in 2009, showed that this, when you did the maths on this, it produced a rotor with an intense magnetic core that then is equivalent to the predicted Dirac monopole. Anyway, it looks like this. We've shown that our model, which I will show you in 3D in a minute, actually produces better results than Alto's mathematical model, whatever they did for their topological monopole. But you have the spin down section, the spin horizontal, and the spin up. And the actual monopole location is effectively at this point, okay? So this is theoretical. They actually showed this in 2015, but we've actually physically applied these things in our experiments. So the D4D ratio was first mentioned here by Bostic and Nardi in kind of like some of the conclusion research that was published here in Physical Review A in 1980. And here you can see these spoked structures, impact marks, which they say are large D4D rings with spokes under the surface. So that's actually impregnating into the surface and leaving this mark. Well, it's a bit similar to John Archibald Wheeler's Geon, which has a gravitational azimuth through the center. This is where I'm arguing that the gravitational beam travels through. And here is a coherent matter structure that they thought they got very excited on the 28th of April 2021 announcing this. But, you know, we'd already published some things a lot more interesting in my view. But anyway, thanks to Nick Moore for sending me this. So here are some impact marks of ball lightning. I'm going to show you in a minute how we produced these structures. And they are found on the anode sheath here in Henk-Uren's Vega experiment. And if I click this, you'll actually find that the overall fractal toroidal structure lines up with one of the impact marks, which has a copper core. And you can see it here. This is a 6-order structure. This is a 4-order structure. This is a multi-order structure. They have these fuzzy edges to them. I'll talk about those in the future, but anyway, we'll come to it. So here we go, and I'm just going to zoom into this structure, and you'll see the non-radiating boundary. or you won't. Didn't show that. I don't know why I didn't show that. Maybe I don't have it on this video. Sorry, that's annoying. Okay. Okay. All right. Well, anyway, you'll see it later on. Okay. Obviously wasn't on this video, but essentially you have this core structure that I just showed you, and it has this non-radiating boundary around the outside, which is a spherical, and this is why you get these craft which are going to be spherical, and that's the only choice that nature gives you if you're going to do it correctly. Anyway, having predicted this 2D section and then predicted the 3D section from deriving it from a John Hutcherson sample, and you know, these are what Tom Bearden was calling a monopole. We then found the collapse wave functions that come out of these things, which are always calcium oxide. Calcium is the highest pure alpha conjugate nuclei, and oxygen, of course, is quad alpha. So you have dec alpha and quad alpha coming together. Both calcium and oxygen in basically all their forms, and calcium oxide, are paramagnetic. So they can live within these highly magnetic structures. The copper here and the carbon orbit around the outside because both copper and carbon are diamagnetic. Okay, so these are various structures. This is 36. This, if it would be a full circle, would be 48, just like the structure. And you can see that this one has a substructure of 6. This has a substructure of 3. This likely has a substructure of 2, which is the minimum. This looks like it's a truncated hexagon. This is a substructure of 6 going on here. So I sent I found these subsequent to this image here, which I found on the train home from the SEM looking at a very large 8K image. And I go, you're kidding me, it's there. Anyway, a few days later, I shared this, and this. The Russian community had already seen this. They'd already seen this. But I shared this, and immediately they threw in the towel, and they started sharing this work, which was done in the classified Soviet energetics program here. And I shared it's called The Bagel Game. You can go and look at the translation at remoteview.icu. And they described exactly and precisely how I had described this fractal toroidal structure would be bound together, although it's not, in my view, correct. And they also said that this is probably a structure of the universe. And in fact, that in that paper, I learned for the first time that the fractal toroidal structure is the only fractal structure that would fill all of space-time and leave no gaps or branches. So there's only one possible structure that can fill all of space-time with no gaps and branches, and it is a fractal toroidal structure. Okay. So in a ball lightning, in an experiment by Henk Uren again, 2 iron plates spaced with some copper pipes with some zinc to get some pyroelectric and piezoelectric things going along with their oxides. It produced a ball lightning. We have it on video where this experiment is going on, and like that, in a slap of the hand, this ball lightning makes this section of this copper pipe disappear, but you always find the most interesting things on the boundary. And on the boundary, we found a 2-order structure with a sort of a spiral coming in, a 3-order structure with a spiral coming in, a 4-order structure with no spiral coming in. Okay, so with 2 or 3, you see a spiral. 4. I explained this in detail, how this occurs and why the 4-order spiral sub n-1 structure does not produce a spiral. This starts to produce a focused beam that comes out of here. 5 produces a focused beam. 6 is absolutely optimal. It produces a very, very self-contained structure, and I believe this is why nature likes to produce hexagons everywhere, and you're going to see that at the end of this presentation. And here in this structure, this is 8, and when you've got 8, you can start to see substructures within inside. Okay, so 6 is absolutely optimal. I didn't actually find a 7, which is interesting. So if you look here, this is a 2-order structure, and what happens when you've got 2 is these disruption beams that I showed you at the beginning coming out of the stuff on the work of Neil Crichton Gold. They puncture through the non-radiating boundary. This is the non-radiating boundary. So it produces a spiral, like a spiral galaxy. So you get 2-arm spiral galaxies, you get 3-arm spiral galaxies. But when you start to get 4, you still maybe get a spiral. But after that, it really starts to become a ring galaxy. Okay, so it works on every scale, but when the reason is I don't show it in this presentation, but you can go and see it in another presentation I call Flower of Life. When you have a 4-order structure with 4-order structures, the disruption beams, which is where the Sothic triangle disruption zone interacts with the torus on the D4D ratio above, it bleeds out, but it bleeds out in the case of 4 and above into the overall non-radiating boundary of the subtor at the level below, and this goes on. When you actually go up to 5 and 6, particularly with 6, then the disruption beams that come out of the n-1 or n- whatever, they actually go into the apple, and so it's extremely stable for that reason. You can go and look at that presentation. So this is the tornadic beam on the right here, coming out of one of these structures, which you'll see later in the presentation, and it makes the steel, this is 3 millimeters thick, this mild steel, glow orange and then unglow orange very, very quickly. So it's literally, in my view, massively yanking electrons out right the way through the material. And it's making it glow orange, not necessarily thermally, but it is obviously hot to a degree. And it's making it glow. So basically, the effect of the fractal toroidal moment and this disruption beam on matter is that it changes all forms of electron interactions. And if you get overexcitement of condensed matter, they result in anomalous glowing and transmutations over time. So this is the sort of thing that was happening in the John Hutcherson system. You get non-thermal plasticity and material flow. It's not molten, it's cold. You get critical fragmentation, particularly where you've got magnetic materials, iron, for instance, because it's ferromagnetic, the monopoles, they can't move to each other. They grow in situ, and then their non-radiating boundary, intense magnetic fields grow and grow and grow until the non-radiating, there's no electromagnetism, but they are fractally growing. And when this go to the next quantization level, their non-radiating boundaries interact, and there's literally no matter on Earth that can prevent that from pushing that iron, for instance, apart. Okay, so you get critical fragmentation, production, capture, and coherence of matter waves. So we showed some coherent matter waves at the beginning. Go and look at the 2013 pattern of Lockheed Martin systems of methods for producing coherent matter waves. And then you get collapse of matter waves into different configurations. And I've showed you these fractal torus of calcium oxide just recently. Okay. The effect of fractal toroidal motion on moment on electron interactions is to start with, at Casimir forces, they modify a modification of the electromagnetic vacuum fluctuations that's what Casimir forces are. So they modify these. They will reduce van der Waals forces or change them, either strengthening or, some people argue these are similar. Polar bonding, such as between water molecules. So, for instance, a ball lightning going into water can make it boil, in inverted commas, and they do energy calculations on that. But I am of the belief that it actually is interacting with the polar bonding, and it just makes the water fall apart into water gas. It's not thermal boiling. And then you have ionic bonding. We've shown that materials are fall apart, like silicon dioxide and alumina, aluminium oxide. Those have ionic bonding. The next one up is covalent bonding in terms of strength. And so diamond is a covalent bond, and also is silicon nitride, carborundum, or silicon carbide rather. And these were the two elements or compounds that Tesla found were most suitable for the carbon button light bulb, and I believe that's because they are covalent. Boron nitride similarly would be most resistant to this, but at some point it will always destroy the matter, and then or disassemble it. And then the last one is metallic. Now this isn't stronger than the other ones, it's just different. It's weird, and this is between crystal grains and electrons shared throughout the metal. So the most weak point is along the crystal grains. So if you look at Jack Houck's telekinesis spoon bending parties, when they analyzed the metal that was bent, they found that the metal had slipped along the crystal grain boundaries, and that is because it's weakest. And so in that way, you can manipulate it that way. But if you pump it up to a certain level, then it'll jellify or fracture, depending on whether it's paramagnetic or ferromagnetic. The material, there will be different behaviors. Okay, so there's some applications here: efficient material processing, cutting, grinding, gasification, cold forming and molding of materials, element creation, transformation, including remediation of nuclear waste, release of hidden energy within matter. This is specific to a 1992 CIA release in 2017 of Russian work, where they're talking about cold fusion being just an aspect of this releasing of hidden energy within matter. We're going to talk about what that is. Condensed matter conversion to other forms of energy, and we're working on a direct matter to energy drive using the disassembly of baryons into electrons and using the energy that comes out of that. Communication without barriers, transmission of large power over thin wires, and I'll show you how that's working, and shielding and propulsion stuff. I could play this clip by Tom Bearden, but he's actually talking about the sample that I want to show you, new analysis that we've done from John Hutcherson's 1982 sample. Challenges in LENR in general is that you get non-thermal but yellow-orange glowing reactor containment failures. You get false radiation signals given and warnings given by various people. You get fake neutrons and fake photons, which fool people into thinking they're seeing things which they're not. You get semiconductor interference, specifically on NP junctions. So this affects anything that relies on quantum effects, so it actually affects consciousness as well. And this is probably how John Hutcherson, for instance, was able to know that his devices were in the sweet spot, because he's, let's call it electrosensitive, but he's actually sensitive to these toroidal moment, the scalar and vector potentials propagating from these large clusters. And so he knows how to manipulate that. Electromagnetic pulses, EMPs, and traveling cluster damage to electronics. We've seen all of this in our work. And anything using Josephson effects, such as superconducting. So this is basically how you detect these things: squids, quantum qubits, and so on. Okay. In terms of a conversation between Brett Weinstein and Hal Puthoff, this was talking about how you go faster than light, and he's talking about exactly the phase singularity, and that leads to the Aharonov-Bohm effect, which occurs, and the Aharonov-Bohm effect you will see occurs in the center of these fractal toroidal structures. Hal responds by not really answering the question. He says, or joining the debate, he just says, and you can go way beyond that. This is the ability to produce this phase singularity that may allow for Aharonov-Bohm effect and changing the dielectric constant, the physical vacuum. He says, so there are all kinds of toroidal geometries, for example, where you have no electromagnetic fields whatsoever, but you have strong vector scalar fields. And since you have no Lorentz force in the absence of EMB, then how can you detect them? Well, you detect them by any kind of quantum detector. You know, I was kind of annoyed because I kind of worked this out, and then he says that. But to be fair, Alexander Parkhomov was using NP junctions in a certain way to be able to detect that. And also you've got Kozarev's bridge as well that can detect phase shifts and can detect the vector and scalar potential. So there's a whole engineering approach concerning which I have 2 patents, by the way, and I've started a new company that involves only dealing with vector and scalar potentials. What are that? Well, just 9 months or so after he handed over the Psychic Spy program to Science Applications International Corporation in 1992, he applies for this patent in 1993, where he has a coil and a countercoil with an electric field, and by oscillating these, he produces what? He produces a toroidal moment, and this is his communication device, and he uses a Josephson junction at the detection end. I have said this affects me, these experiments affect me during experimentation. I've observed that, and I've commented it on live. I suspected whatever was going on before I knew what might be going on was working on the same way that consciousness works. And in June 2000, June the 15th, published in Nature Human Behavior, they showed using functional magnetic resonance imaging that there are magnetic vortices and counter vortices in a brain when it's conscious doing cognitive functions. And if you have a magnetic vortex and an anti-vortex, 100% certainly that produces a toroidal moment. So it is certain that toroidal moments are produced by the brain, which means the brains can be influenced by toroidal moments, which means we can both sense exotic vacuum objects and we can be manipulated by exotic vacuum objects. And this has implications for precisely understanding how John Hutcherson did what he did and how you would psychokinetically interact with drive systems and propulsion systems and any other kind of systems that use these fractal toroidal electromagnetic structures. Okay. So the transmission of many kilowatts over 8 micron wire, this was shown also to Tom Beard in 1992. You could call this cold electricity. Matsumoto rediscovered this in his own way, and it's published in his book, Steps to the Discovery of Electronuclear Collapse, in 2000. But essentially, it is exactly this structure, a toroidal moment structure, which carries, because it's fractal, it can carry 1 ion for every 100,000 electrons, and it's just using the potential along the wire as a guide to transmit the energy. And so they showed an 8 micron wire transmitting, I think it was 25 or 40 something, I think it was 25 kilowatts of power down an 8 micron wire. Okay, so it's demonstrated Tom Bearden's team in 1992. It was discovered independently by Matsumoto in 1996. It was published again on a Russian television program in 2000. And Shishkin argues that you could also do this transmission of energy over a laser light, effectively creating a wire in the air. And unfortunately, that allows for ridiculously dangerous weapons. So the vortex spiral that you get, because I believe a tornado is exactly the same toroidal moment structure at the top, the disruption beam comes down. And what you're seeing in this water column, I argue, is the disruption beam interacting with the water here and causing the polar molecules of the water to convert into water gas, and it's lifting the water gas up here. It lifts up here. The reason you see these smoke flares coming off at an angle, and they're not representing what you would imagine would be the extremely fast winds represented by the dark water here, is because there is possibly relic neutrinos here coming in, and they are effectively affecting the ability of electrons to behave normally. And there is a event horizon here by which there is zero friction between the fast flowing air here and the ordinary flowing air there. And we are currently replicating this device by Frank Polevko, which has a disruption area here, and it will also have disruption areas in the N-1 tour. We haven't really explored what we need to, which is increasing the temperature above the boiling point of water and introducing the charge separation in there. And so that is a work in progress. But this can turn and dehydrate materials with bizarre efficiencies. Okay, so, and this again is exactly the sacred geometry. This is literally the Vesica Pisces, and it is also at this level the Chi, which is the life force, the prana, the spiritual energy, and the Rho coming through the center. Rho is density with torsion. So whoever made those Macedonian coins 400 years before Christ was born and called them Thunderbolt coins because they represented this structure on those coinage. Now, obviously, their means of numeration, the numismic means of trade, knew, or someone knew that informed them what ball lightning was, and this is effectively ball lightning. Okay, in 1979, my father showed me at least 3, maybe 4 lights in the sky going blip, zip, 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 boop, and disappearing. I've discussed this on my blog. You can go and see the interview there. Long before I got to where I am in my understanding now, but I later found that on NASA's actual website, they have a paper from A.C. Holt looking at an interplanetary drive system. And when you look at this, you have a phase singularity in the center where the magnetic reconnection causes a vortex to be centered, okay? And this exactly and precisely is a toroidal moment structure. So they are saying that an interplanetary drive would use exactly this process. It's exactly the same thing. This is an image from Maury King. He said in his work, having met Ken Shoulders, sadly I never got to meet him, but he said that firing an Evo through a hole was produced the most powerful thing that he had ever observed. He called it the Evo water gun. And that's very interesting to me because if you take this process of wire discharge machining, you actually have not sparks. They don't create an arc. They create it just below an arc. And so my argument was that this is doing exactly the same thing. It's producing these non-radiating boundaries that disrupts the metal, and using a brass wire, you can even cut through silicon carbide. So this is the original 300 or so. This is the scale down here, 300, so it's 250 micron or so wide brass wire. And I went to visit a facility that has this. I took some before material, I took some after material. I've got a lot more to look at. But it literally took me something like 90 seconds to find the same structure. You have a bright sphere here, a dark sphere here. So this is bright, this is heavy, this would be the yin, this would be the yang. They're exactly spheres. And then you have this disruption beam. It's always a wave. And then you have, like you have on the Om symbol, a little curve off to one side representing the structure here. This is the guts of a ball lightning that blew up, but these curved sections taken out here are the result of the interaction, probably of the apple with the cutting wire, but the same thing would be going on with it within the metal. So this is a beautiful demonstration that people can explore the process of how this works, and it effectively is using the principle of exotic vacuum objects going through a capillary, because it basically it's a very fine hole, and that they throw a water jet through there as it's at high pressure as it's doing this discharging, and it's not an arc. It's not an arc. So here the same kind of process is going on with this steel cutting. And it's very good for cutting carbon steel, because carbon doesn't want to transmute and the iron doesn't want to transmute. So this is an HHO generator in China, and you can cut through 0.5 meter or even possibly even 1 meter of steel. And the reason is because of the hydrodynamics. As it's coming in, it produces the toroidal vortex, which starts self-assembling the coherent matter, and then the coherent matter can cut through very, very cleanly. So what we demonstrated here with HHO in form of Mars gas on tungsten, instantaneously transmuting the tungsten here, is what can be achieved also with HHO. So a lot of the magic of HHO is because it produces, in my view, coherent matter, and it uses that. It then leads to this fractal toroidal moment, and the ability of this front end here to literally destroy any matter that it comes into contact with. And in fact, Ken Shoulders said in one specific paper that based on, if you were to try and compress, for instance, alumina or silicon dioxide or whatever, some of these refractory ceramics, it would be the equivalent of a pounds per square inch of 200,000 pounds per square inch. Now, if you put that in context, the Raptor 3 of SpaceX, I think its chamber pressure is 5,100 pounds per square inch. So absolutely massive levels of potential for propulsion. Okay. So here I told you about metal forming. This is what heat does to metal. This is This is what let me see if I can get that right. This is what heat does to metal. This is what compression does to metal, and this is what deformation, bending does to metal. You're shifting the association of an electron in the sea of electrons that moves around between the nuclei, so that the nuclei can shift from one location to another. Well, this is HHO, which you just saw transmuting tungsten. And when it transmuted tungsten's melting at 3,000 and whatever degrees centigrade. Well, I thought I'd try something that doesn't auto burn in air, but has a very low melting point. I chose indium foil with this HHO, which melts at 156.6 degrees centigrade, and it did not melt. No, what happened when I put the jet on there is it turned to a rubber sheet. It turned to a rubber sheet. And what happened then is it started to transmute the material as the clusters built up in there. And when it started to synthesize things like carbon, which we see on the SEM, it then thermally heated up and then melted and dripped down. So I believe that's the same thing that has occurred when when John Hutcherson was working with Alec Pizarro, and he was building up the monopoles, the charge clusters inside this aluminium block, which was glowing yellow-orange. And then they turned off the electromagnetics, and he went over and he went to feel it. It wasn't glowing yellow-orange anymore. He went to pick it up, and he could feel that it was cold. And when he went to put his hand in it, he left these fingerprint marks in there. So we've replicated John Hutcherson with this experiment by the coherent matter that's produced by HHO, and it's just it's the same phenomena, just one's kind of like non-contact, and this is a little bit more involved. So you should listen to John Wheeler here. He talks about how when you get these structures, effectively you would create a gravitational wave, and then if you take multiple of these structures and make a fractal structure, you would end up with a gravitational wave that pinches in on itself and then it allows for collapse. So if you just read this listen to this section from John Wheeler, you will have a good understanding of how matter collapse can occur into these situations, but we won't go into that. Don't need to talk about this, but that was what I showed earlier. Oxygen goes into the center, carbon goes on the outside. Oxygen, why? Because it's paramagnetic. Carbon, because it's diamagnetic. The same structure occurs in a collapsing water bubble. As you can see here, this is the non-radiating boundary. The bubble expands to the size of the non-radiating boundary, which is quite wonderful to see, and so on. This is our proposed path to matter to energy conversion. When you look at this with your eyes, all you see at the end of this pipe is a full or nearly a full sphere, like a ball lightning. But because of the sensitivity adjustment on the camera used to look at this, we can look through the outer sphere, the non-radiating boundary, and we can literally see the torus, okay, the torus, and that has this tornadic beam that comes down into the tube, and it's that base of that tornadic beam that is interacting with the metal on the outside where you saw that orange spot moving around. So you can imagine a tornado moving around, and when you see this flash, it's where it's destabilized and it shoots off from this effective cathode to the anode, leaving those different levels of fractal toroidal structures that we observed on the fused quartz in the Henk-Uren experiment. So we will be using this with a method proposed by Mikhail Solin for direct electricity production. It's not that this is spinning itself, it's that it spins at incredible velocities, charged particles around it, and that allows us to produce electricity through induction. So this allows to consume matter and convert the energy contained within that matter into angular momentum, and then to convert that through induction into electricity generation. So this is matter to energy conversion. Okay, so that is our proposed method. We might stress it with a magnetic field like the Chukhanov method, but there we go. So just to clarify here, the toroidal moment produces the Aharonov-Bohm effect. And the mass for this was already done by Afanasyev and Dubovik, the sadly departed researcher that both discovered the toroidal moment and gave us this paper in, I think, 1992 or 3. And this was in a paper called Some Remarkable Charge Current Configurations, published by the Joint Institute for Nuclear Research in Dubna. Okay, it's actually quite embarrassing how far the Russians are ahead of this. But in fact, it says here in Figure 13 in this paper, the magnetic time-dependent Aharonov-Bohm effect for charge configuration discussed in the text. The time-dependent magnetic flux differs from zero only inside the impenetrable torus T. Outside the T, the dependent of time electric strength E differs from zero only inside the torus hole. Okay. So you have something in here which is unique, which is at the n-1 level, and you have also in the hole. Okay, this is entirely consistent with all of the physical observations we have observed. So effectively, spin material is good food for this system, but of course, if you ionize something, it can play a role. Non-spin bosonic nuclei get kicked out. So often in these reactions, you see production of helium. This is the product from stars. I believe stars are using the same process, not the process we've all been led to believe. If you look at most of the interstellar dust, it's carbon. And that's why I think the same process is what's causing that interstellar dust, and that is the product that this process likes to produce most. And oxygen is the most abundant element in the Earth's crust by far. It's like practically half of the Earth's crust, and it's specifically this isotope. And so that's why I believe that's synthesized. Okay, so now Nikola Tesla absolutely, certainly, and clearly knew this. Why? Because this is his photo from the 1930s, where he was promoting the weapon to end all wars. He said it produced an invisible Chinese wall, Chi being the life force, and it's exactly what it really does. And in it, he has a tie with the symbol phi on it, and he has exactly the sacred geometry cut off at the top of the disruption area. So this is another Henk Uren experiment. It has exactly and precisely the sacred geometry structure on it, and it has a wormhole. The matter is pushed into a wormhole, just as said by Takaaki Matsumoto. Only inside this black circle, which is just outside this white circle, do you see the deformation of the brass here. And the material is punched into a wormhole, comes through and comes out here and punches a hole through here. It has this disruption zone down here, and because of its tornadic structure, it's actually a triangular shape, and we're going to look into that in a minute. And this is the first time this has ever been disclosed. Okay, so thank you for giving me the opportunity here. The material that goes through here, this hole here, gets deposited exactly in the sacred geometry structure with the golden, Sothic triangle going into the center here. This is exactly the structure you get in a tornado, in a vortex soliton like this one here. And again, with Tesla's device here, the bit that gets disrupted, as in our experiments, is where he cut off the top of this flower pot. This is the Vesica Pisces, cut off at the point that the material comes into the bottom. And if you actually look at this going down to the bottom, he's actually got exactly the right proportions, and he has 4 supports. You need a minimum of 4 to make a stable beam that comes down. Absolutely, 100%, Nikola Tesla knew exactly how this works. Okay, now if I go on to the next slide, what I call the cardioid infarction. We're looking at what we just showed you here, but just outside with a more crummy camera. You can see the subtors here, and this is where the brass is laid down. The material is taken from here, it goes through a hole, and then comes out of here and gets deposited here. Okay. This is some close-up of part of the structure here. So this little part here is this vortex here. You have a hexagonal or a geometric structure here with a vertical pattern here. That is here. I haven't shared, but will do in the coming months, the SEM analysis of here. Inside certain parts of the sacred geometry structure, you see incredible things, but not outside, only inside. And of course, this is exactly the model of the Great Pyramid. Okay. So here's another close-up, and so on the outside. So what we're going to look at is the disruption on this area here. Now, outside of here, this is literally and precisely and only brushed brass. But inside this triangular area, you're going to see something really, frankly, amazing. Okay, this is it. So in this area here, looking at the SEM in Prague on the 17th of August last year, and this was shared a few days later in my presentation in Szczecin as one of the backgrounds. You've actually already seen this in this presentation. There is a hexagonal array with a point focus, a hexagonal array, okay, exactly and precisely equivalent to that predicted, I think, in the 1873, I think, by James Clerk Maxwell as a model for the ether. And so I believe that what's going through here is coherent matter, but it's more precisely coherent matter constructed of whatever the ether is, and it's producing disruption. This is where the disruption beam is in this triangle. This is where the subterranean unfinished, as it's called, layer of the Great Pyramid is, and that is here. Outside of this area, it's straight brushed aluminium. Inside of this, you have this deposit, whatever that is, and I know what that is when I go back through the data, but you have this hexagonal array. Now, the interesting thing is here, are you ready for this? This is boom 2. This is John Hutcherson's sample. from 1982. This is another sample, I believe, well, from between 1979 and 1982. This is also a sample that's never been analyzed before, from between 1979 and 1982. This is the end of a sample I asked George Hathaway to let me have. Thank you very much to George Hathaway for both of these samples. I will show you in a presentation specifically on this that we have imaged this and exactly replicated what all other people have observed when they've observed this material from John Hutcherson. And it is these black spots. These similar kind of black spots are being seen in other research in Japan in cold fusion reactors. And this is effectively ferrosilicon. It's not so much the silicon content that's so interesting to me. It's the fact that also on this crystal grain here, you actually have regularly spaced, like a sapphire anode, you have these toroidal circular structures where the material is consumed, and it's obviously split. If you look at the Venetian blind-like look of the split of this material, this is exactly and precisely as described by Tom Bearden in a video recorded in the 1990s. 100%. There is no fakery going on with what was observed by multiple labs across the world, but in these samples produced by John Hutcherson. In this sample, and I will go into this in more detail with the SEM at a later time, but you see the same kind of thing going on as you see here and here, these cellular-like structures. Now, you do get this with aluminium oxide, and this is an aluminium or alloy. But in the center of these structures, these are iron-rich in the center of each of these structures. That shouldn't happen if you were just getting aluminium oxide. You shouldn't get iron forming in the center of these. And moreover, this structure, which is in the center of lots of other centers, structures, this is copper rich. This is copper rich. Okay, so it would appear that in the center of these smaller structures, it's producing iron, and in the center of a much larger structure, it's producing copper. Copper is heavier than iron. So you can see how, as you build these fractal structures, the bigger they get, the more intense the fractal toroidal phase singularity at the center gets produced, and you end up by producing heavier and heavier elements. And I believe that this is a working model for what actually are black holes. At the same case, we have some structures in the center of these. Now, I want to do a direct comparison between this structure and this structure. This structure produced in 2022, imaged in August 2023. This structure produced circa 1980 and analyzed in the same microscope session. I think it was on the same day I looked at both of these. This is what you see. The distance between the monopole structures on the brass sample from 2022, produced by Hutcherson and imaged on behalf of donors of the MFMP by my good self in Prague, is almost identical to that of the monopole structures on the Hutcherson sample produced in ferrosilicon in 1980. I believe that in multiple ways we have replicated effects observed by John Hutcherson. Here is a close-up. So these are scaled to exactly the same scale. And this is exactly the same piece of geometry, and I just dragged it down and offset it. Okay. This, the brass here does not look anything like this, but only in this disruptive point, this exact and precise disruption point. And I will come on to describe how the same thing can have a much larger area where you would get these structures forming within material in other work and in a book. Certainly the labs that looked at this, the Max Planck Institute, George Hathaway, some of the national labs, they had not observed this effect before. So, there we go. Here again, this is looking at the brass sample of Hutcherson. And here you can see I noticed this pattern on the top where things seem to be vectoring in with triangular sections, okay, there's actually multiple of them, and I wanted to compare the size of this vortex structure with the bit in the center in this hexagonal array compared to the deposit that's on the top, and effectively they are the same scale structures. So lastly, I want to refer to the work of Binzhuan Huang. You can go and look at this, but I imaged that in the exact place that I am in now on 18th of March 2024. And the idea is that minimally you need a wheel within a wheel within a wheel. Okay, well, the disruption area of this oval structure is exactly at the precise area that you have a hole of material that is consumed here. Okay, the center of the two the n Tor level is exactly and precisely where you see these two disks. The apple shape here, this crashed in from the side here, and it's kind of got this distorted like skull shape here. But anyway, it's like a scream. But what happens is that in this is the non-radiating boundary area, and this is the weak point, because this is the area where things come in and come out. I can show you many, many examples of spheres produced where material is ejected from here by both myself and other authors, by Slobodan Stankovic in 2019, and also by Takaaki Matsumoto in the 1990s. Okay, so this is where things come out, and we've seen this in many, many cases, but in this case it's very visceral, because the two wheels that would have been forming this structure in the n-1 have come out, and they are here, okay? And this one has broken, and it's spilled out two wheels. It's left a shadow here on this one, but we've got the sub-Tor here. So this is the n-2 Tor. This is the n-2 footprint, like the footprints we saw on the Hutcherson sample from 2007. This is the n-1, which is ruptured, spilling its guts here. And this is an n-1. And those two were originally here. And those are exactly and precisely the shape of this part of the fractal toroidal structure. Okay, so, and from the top of the apple to the midpoint where the gravitational force is strongest in the center of this toroidal structure. And then from this to the center of the disruption zone, thank you to Tony Yaboni. And this would be true of all fractal Tor substructures. This is the golden ratio. I believe that this is the reason why matter organizes in the way that it does, both in spirals, triangles, and gold ratios. And we see this in almost every experiment we look at. So lastly, the plasmoid, this is the apples, two apples on a very large structure. I've actually got this at 8,000 pixels by 8,000 pixels. So this we can publish this at wall size at very high resolution DPI. But you have the oid spiral anti-vortex here and the oid spiral vortex here. These are a pair, and together they make an n-level torus structure, and there will be a disruption beam coming down here. We have unimaginable numbers of evidence of this. We can share samples with labs that agree to doing material transfer agreements where they say precisely what they're going to do to analyze it, the time frame they're going to do it in it, and commit to being open about all of the analysis. And I will educate them as how to record live their analysis sessions so they can't fake anything, right? So we have many meters of this material in Taiwan, produced by a 50-year professor of the top university in Taiwan, Professor Binzhuan Huang. And he never expected this to be in here. I could not have possibly expected this level of data to verify the effect. This is repeatable. It can be done by children from the age of 3, but I think you'd need to be the age of 5 to repeat this in an ultrasonic tank. And it shows the principle of the yin-yang. This is the yin-yang, and inside the yin-yang you have a yin-yang, and inside that yin-yang you have a yin-yang. So I would encourage everyone to join me at the bit.ly/Cosmic Summit, where you will be able to spend quite a lot of time asking me any questions you like. I hope to bring some samples, and you can see those too. And so forth. This is occurring next month in North Carolina. And with that, I will say thank you very much for your time. And I will say again, thank you for the gift that was given to the world by Vladimirovich Dubovik in 1967 that we are now just starting to understand and utilize in practical technology.
That's amazing. Bob, thank you. Thank you, thank you, thank you. So let me do this. I want to take down the screen presentation for just a moment. I'm going to put everybody on stage. We need to give Mr. Bob Grenier an enormous applause. Bob, thank you. Thank you. And for those who don't know, Bob, you could probably easily do a presentation 3 times that long, and the amount of data and the quality of data would be just as high all the way through. So you have tons and tons and tons of data going on there.
I could probably do an 8-hour presentation on the stuff that we got the last 2 days.
You know, it's interesting. I'll tell you, if it's okay, I want to put up real quick. I have a few slides. I have some Searle stuff that I wanted to show the audience too. But here, let me present. I wanted to share this one though. So this was when you were talking about things. This is a story. The original was PDF. Proton 21 solid state nuclear fusion. You guys can all look this up. It's on Medium. Just look up Tim Ventura Medium Proton 21. I would urge you to look up everything that Bob has showed you. Look up Bob's Bob's thing. I'm going to take that down. So in this one, Proton 21, they found a black spot. They were using a proton beam doing nucleosynthesis work, and they kept putting particles into it, and they said it ate everything they threw at it. It was either protons or electrons. And
so actually, I can speak to that because your interview was absolutely seminal in my understanding. So I have to give you a big shout out, Tim.
Okay.
And I actually presented that data in Russia to the Russians in 2018 in Sochi. And that's when I revealed the first third of my original O-Day slide deck. And essentially what they had is they had a secondary ion mass spectrometer, and they had one of these accretion disks. So if you don't know about the Adamenko experiments, they would take a metal pin that they would made out of ultra pure material. Typically it would be copper, but they tried all of the metals. And then they would have, say, an equivalent disk of, say, copper. And then they would have a 300 joule discharge that they would go through a dielectric barrier discharge. And by that, what you do is you build up the electrostatic pressure behind it, and then it has the breakdown. So you get an instantaneous cascade. And so you get this instant shocking pulse, which was key to Tesla's approach to dealing with matter transformation. And that would hit and condense onto this pin. So all of that instantaneous electron flux would go into the head of the pin of that, and you would literally get it peeling back like a banana. And then you would get these ejecta coming out radially from that pin, and it would interact with the material. Now, in his patent in 2003, he had showed a hollow iron-rich crenellated sphere. And in an interview in Ukrainian news media in 2005, he said that he predicts that the nuclear reactions occur in there and is due to a dense cluster of dark matter that forms in there. But what he said was, in specific reference to that thing that you've just talked about there, under the secondary ion mass spectrometer, what you do is you have a primary ion. You know, it's a heavy ion typically that you don't expect to be in your sample, and you fire that into your sample, and it spillates. It smashes off a load of ions that then come into a drift tube, and you measure the different masses. Well, what he found was he was firing these primary ions in, and he wasn't seeing any secondary ions on. Well, he turned off the power, and there's a photon multiplier on the top. It's like it gives you this green phosphorescent look. And what he saw was in the place that they were firing the ions, there was this exponential decay, and they repeated this something like 12 times. Okay, and then what they found was they weren't even seeing the primary ions. The actual ions they were firing in were disappearing as well. So basically no matter was coming out of this, but light was. A bit like you might have on an event horizon of a black hole. And then they did further experiments around the outside. They found subquanta around the outside where they had the same effect occurring. And this points to a phase singularity in the center and regular phase singularities around the outside. That is a fractal toroidal structure.
Yeah. Well, so Bob, actually, why don't is it okay to put the slide back up with the summit? Maybe you should put the slide back up.
Yeah, sure, absolutely. Let me get that for you. The discount codes are changed now. It's Cosmic 50. But
Yeah,
I was
and we'll give
originally, and I
people
think
another
I still
minute.
am. Yeah, I'm going to share it now.
Yeah, and EVOs are it's giant. I think a lot of people have difficulty understanding it, right? I have difficulty understanding it. So it's complex. It gets very heavy duty in terms of the physics very rapidly, but
I
there's a
think they've
lot
been well
there.
described by mathematical equations, principally by Dubovik. Now, Dubovik worked with Shishkin and Korols. Both Shishkin and Korols, to the best of my knowledge, are alive. I actually have spoken to Shishkin the last 2 days. He reached out to me after my last presentation on cavitation that we did earlier in the week, and informed me that Dubovik had sadly passed away. But what they found in their team during their work and post their work, working at the All Russian Institute of Nuclear Research in Moscow and in Dubna, the whole city that's dedicated to this stuff, but they found that it would appear that hydrogen isotopes are 2,000 to 4,000 times easier to produce etheric matter clusters than any other element beyond lithium. Now, Tesla found, and you can see this in Secrets of Cold War Technology by George Vassilatos, that Tesla found that it was beryllium, magnesium, and aluminium that were the easiest in his work. But of course, he wouldn't necessarily have had access to hydrogen isotope. Of course, he had hydrogen, but it's not a dense target to smash something towards, So, and so to produce, and what it is, it's proper charge separation, and it's the hidden energy within matter. So the neutral EVO, you could argue, is a fractal toroidal cluster of etheric matter, dark matter, potentially cold relic neutrinos. These are not normal nuclear neutrinos. And so you could imagine that fractal toroid made out of these relic neutrinos, okay, and then they're bound together because the actual relic neutrino has its own toroidal moment, so it can be bound into a fractal cluster by its scaling toroidal moments. Then that structure, because electrons can interact with these things, and they also have their own toroidal moment, they can then become wrapped up and take on like a fossil gets formed, and probably is exactly the same way a fossil gets formed, actually. The electrons become part of the structure, and then they can bring in one ion per 10 to the 5 electrons. And so you can then have things that are both positively and negatively charged, but because the electrons can go in and become Cooper pairs, they can present a charge of only -1, even if you have 10 to the 23 per centimeter squared of electrons in the exotic vacuum object. So they can present as neutral, they can present as positive or negative, they can cluster, the clusters can cluster into bead chains, and so on. It all becomes logical when you understand the toroidal moment, the fractal structures.
Okay. Well, thank you. Thank you so much. It's, again, truly an honor to have you present today. It's absolutely wonderful.
It's my duty.